Hello everyone, I am Aves and today we are going to learn to solve uncertainties related to your course 9702 in AS level in CIE. Now, so the first thing that you must understand is that basically there are three types of uncertainties that might be given to you in your exam. So the first type of uncertainty is absolute, and absolute uncertainty is generally given as plus minus with a value and maybe some unit, right? And then in the second way, they might give you an uncertainty such that it's in fraction or percentage. Now, in fraction form, they might give you something like 2 by 5 plus minus, all right? And then in percentage, maybe something like 5% or 4% or whatever. Now, you must understand that these are two different things, right? And usually, when they will give you in fraction, they will never give you a unit beside it, right? So, in absolute, you have to write the unit as well as the correct significant figures for the value. Now, you must remember, and that's one of the most important thing is that the absolute uncertainty must be written in one significant figure only. And most of you make the same mistake, although you have calculated the value correct, and maybe your uncertainty when you calculated was 1.9, but you forgot to convert it into 2. All right, so now it's wrong, right? So you must understand that basically this value, although according to your calculation might be correct, but that is the correct answer you should write. All right, so this is not correct, so you should always follow this rule. Now, so there are basically two ways of handling uncertainty, and the first is when we are looking at um, things like addition and subtraction. So addition, and in addition subtraction, let's suppose if there are two values given to you, let's just make up two values. So there is a value a and it's given as maybe 2.0 plus minus 0.1 mm. All right, and then there is a value b and it's basically 3.5. Let's take this, and 0.2 millimeters. All right. Now, if you're asked to do a plus b, and that's the addition operation, so you must understand that this value, right? So this value, which is the mean value, all right, and this is the uncertainty, you have to just add the mean values. Like when we add it, so it's going to be 5.5 and then plus minus, and then we have to add the uncertainty as well because already these uncertainty are written in absolute. Okay. Alright, what you need to understand is that I just made a mistake here. Let me just correct it. Okay, so you just need to remember that when it's given in absolute, you can directly add them or subtract them in a case where it is only an addition subtraction. So when you add it, it's going to be 0.3 mm, and that's your answer. Now, if they've similarly given you a subtraction operation, so it's a minus b, so it's going to be minus 1.5 then, and when you do that, you must remember no matter what, the uncertainty will still add up because of the fact that you have done an operation with individual uncertainties like this, so you have to add them, and now this is your answer. Okay, so what you need to understand is that no matter what, uncertainties always add up. All right, uncertainty is the error in your reading, and when you do whatever with it, all right, when it's addition or subtraction specifically, so they will add up. All right, so that's the answer. I hope this is clear. So let's just move on with the other operations. So the other operations include multiplication. division, and when you take power, obviously if you look at power, it's already it's like multiplying with the same number, or maybe it's like dividing or whatever. But let's just see. Okay, so if this is the case and they give you like an operation where they say, all right, you need to do a square times b, okay, or maybe let's just do this first, and then we can include another uncertainty. Maybe there's another uncertainty already given to you. Let's just write it somewhere. So let's say that there is another uncertainty C, which is 1.7 plus minus 0.2 millimeters. Now they're saying you have to do this, right? A squared times B divided by C. Now, to solve this, first of all, you must understand that you cannot do it. You cannot just simply add the uncertainties like we did in addition subtraction. In fact, you have to convert them into fraction. Now, I have just learned a way, and then I'm also going to teach you this. So first of all, we're going to look at the value. All right, we're going to find the value of a squared times b divided by c. All right, and when you do that, it's going to be 2.0 whole squared times b will be 3.5 and then c would be 1.7, right? When you do that, let's say this operation was known as d. So the value of d would be then, let me just quickly do it on my calculator. So okay, then it's going to be okay, so it's on my calculator the value is 8.2, all right, and 3.5. So because I'm taking all the values in two significant figures, so basically on my calculator, let me just write it, it's 8.235, but the actual value I'll take it because they're all two significant figures, so I'm going to take it as two significant figures, and that's 8.2. Now I got the answer here, right? Now I'm going to find how I'm going to find the uncertainty in absolute terms. So what I will do is I have to find the uncertainty, so I'm going to write as delta d, that's the uncertainty, upon d, and that's if you really look at it, so this is just a fractional uncertainty, right? So I'm just finding uncertainty, the uncertainty, and it's being divided by the original value, right? So in this particular thing we had a, so I'm also going to fraction the a out, and then add the other value, that's delta b upon b, that's uncertainty in b divided by b, and then it's delta c upon c. Now adding all up, but one thing that you need to remember, and then you have to look at for the power. Let's suppose if, like, we can see there's a power 2 here, so with this we are going to multiply 2 here. I hope that's clear. In case if it was some other power, maybe 3, 4, 5, or maybe under root, so we will just write the value of that particular power here. So I hope that's clear. Whatever value is squared, or it's rooted or whatever, so you have to just multiply the value of that power here, all right, with the same fraction. Now once we do that, let's just put the value. So we're looking at delta d, that's our aim because we already have 8.2, and then we're going to write 8.2 here, and then 2, and then a is 0.1, and then divided by the value, that's 2.0. Then b, that's the uncertainty is 0.2 divided by 3.5, and then c, which has an uncertainty of 0.2 and it's divided by 1.7. Okay, so I'm sorry. Okay, so now here we're going to find delta d, and when we do that, let me just quickly do it so you know the answer. So it's 0.1 times 2 divided by 2, that's 0.1 plus 0.2 divided by 3.5, and that's 0.0571. Alright, and then it's 0.2 divided by 1.7, and then it's going to be 0.118, I believe. Okay, so I'm going to take 3 here. Now when we add it, so it's going to be, and here it's 8.2, sorry. Now when we add it and then we multiply 8.2 with all of this, okay, so let's see what happens. Okay, all of this, just end of the page, so it's not letting me write there, but let's just do it. So 0.1, let's add 0.1 plus 0.0571 plus 0.118. So the answer here would be 0.2747 times 8.2. Now let me just multiply the whole thing, okay, the whole thing with 8.2, and then I get 2.25. The answer is 2.25. Now, however, when I write this, so basically I'm going to write it in such a way that I have to write 8.2. That's basically one decimal, and then I'm going to write my uncertainty as plus minus 2 millimeters. Also, you need to understand that if it's the uncertainty doesn't show you a decimal because it's not, so you must make sure that the mean value should conform to the same decimal places. So I'm going to round it off. So the correct value according to the rule is 8 plus minus 2 millimeters, and that should be the answer um, in your answer space. So I hope it's clear. The video got a bit long, but in the next part we're going to solve some problems from your exam questions and see if you understand. Thank you so much.